Yes, can.
So last week we have discussed tutorial 1 and 2. So today we will continue with tutorial 3. I believe that you have uh, your mass lecture last week, which covered chapter 3, right, on determinants. So today we will do a tutorial on determinants. Okay, so we start with question number 1. So evaluate the following using method mentioned on page 2 and 4 in the lecture notes. So this is actually a basic methods to find the simplest methods to find determinants. Okay, so do you have any problem with these questions?
No.
No? Anyone have problem with these questions? You can write it in chat if you want me to discuss. Tak perlu I need to discuss in detail about this. Okay, let me just show you. So this is the answer. So basically, for 2 by 2, you just need to multiply, cross multiply. Okay, you just need to cross multiply. So you just need to cross multiply and then minus with the other multiply lah. Okay, so in this case, t times t minus 1 minus, it's actually minus negative 3 times 2. So that's why you get plus 6. So you have this as your determinant. As for 3 by 3, so you need to multiply, let's say you want to do let's say you choose the first row. So basically for this type of questions, if it's 3 by 3, you look for rows that consist of most zeros. Why? Because it will shorten your calculations lah. Sebab kalau zero, then you don't have to calculate banyak-banyak kan. So in this case, I believe they need to choose. Okay, let's say if we want to choose the third row, it will be better, it will be easier lah. And then also you have to know the positive minus of the position of the positive minus in the matrix. So here will be positive, negative, positive, negative, positive, negative, and positive, negative, and positive. And then you choose one row for you to calculate. In this case, I believe they choose, let me see, they choose the minus 0. They choose the first row. Kalau yang inilah, kalau example inilah, you can choose the third row if you want. You can try to calculate. If you choose the first row, it will be t minus 1. So it's what, t minus 1. And then you cover the first row and first column. And you will have t times t cross multiplication, t times t plus 1. So the t times t plus 1 minus 0 because of 0 times negative 1 here. So minus 0, so tak perlu tulis lah. And then the next one is minus, plus minus is 0 kan, 0 here. So it will be 0 essentially. If it's 0, you don't have to calculate much because of anything times 0 will be 0. So if you choose the first row, so this will be 0 here. So you cross. Oh, dia bukan pilih the first one ni. Let me do lah. Follow this one, right? So we have, let's say we have t plus t minus 1, 0, 1, negative 2, negative 1, 0, 0, t plus 1. Let us choose the last row. So it will be 0. Kita perlu tulis pun, it's really 0 kan. And then this one is plus, minus, so minus also 0. And then plus t plus 1 times with cross multiply, t minus 1 times with t minus 0, right? Because of negative 2 times 0. So you will have t plus 1, t minus 1 times with t. So we have t square minus 1, correct? Times with t. So at the end, you have t to the power of 3 minus t. So this will be your determinant. Similar as the answers. It's just that this one is much more faster. Because why? Because you choose the rows with the most zeros. So basically, kalau nak cepat, kalau nak more easier for you, choose rows that consist of more zeros. Okay? Basically, this is how you calculate the determinant. This is the most simplest way to calculate the determinant. And then question number 2, you compute the following determinants using reduction. So this, you need to calculate your determinants using reductions. So in case the questions or the problem did not ask you to use which method, did not specify any methods, so you can choose whatever methods you want to calculate the determinant. But in cases where the question did specify you kena guna method apa, then you follow the questions lah. But in this case, question 2, they specifically said that use reduction to do this. Okay, let me show you the concept of the basic concept of reductions for determinants. So I hopefully by now you know how to do reductions already. You practice how to do reductions already. But for determinant, every time, for example, this you want to find determinant for this matrix. Every time you change row, see here for the first step, you change row 1 to row 2, right? Because of why? Because you want to have your leading one here. Okay, so every time you change row, to find the determinant, you have to put negative in front. Sebab tu dia ada negative dekat sini because of you change the row. Okay, so you change row and then you reduce as usual. So you zero out. Next is you zero out 2 here. So you just need to zero out 2 using the operation here. And then one, you have a triangular form. Triangular form means below diagonal. Below diagonal have to be all zeros. That is triangular form. So to find determinant, you have to reduce your matrix into triangular form. And then once you have this, and then you just multiply the diagonal. And then with the, of course, the positive minus lah. You have to, kena tengok jugalah, alright? So that's why it's negative 1 times 7. So your determinant equals to 7. So that is 2 by 2. Sekejap ya. Right. So continue. Okay. Okay. So now look at B. Or B, I don't think you have to, because it's the same, it's 2 by 2. I don't have to discuss anymore. So you can see, I just go through. If you can see, when it change column as well, kita boleh change column juga in reduction. Remember, we can change column, we can change row. If you change column as well, we also need to put negative in front. Okay, negative 1. And then the next step, because once you have change column here, you want to change the leading one to become row 1, right? 1 here become row 1. So you change again. So you put a negative 1 again. So because of negative and negative, it become positive. So you don't have to, right lah? And then you zero out lah, macam biasa. You zero out, you do reductions. And once you have the reductions in triangular form, so you just multiply the diagonal. right? As for C here, you see it's already in triangular form, so you don't have to reduce anymore. So what you do is to find determinant, you just multiply the diagonal, so it becomes negative 10. Okay. For D, it's 3 by 3. How you do, you need to do reduction. So because the first step here, we change the row, that's why we put negative. Okay, and then we reduce, we zero out 2 and 3. So we zero out, we just use these operations. If we zero out the value, 2 and 3, we don't have to put any negative inside. Only when we change row or we change column. Okay. Okay, now next is we zero out negative 7 using this formula here, using this operation here. And then we have a triangular form. So what we do is we might times negative 1 times 1 times negative 3 times 13 over 3. You have your determinants equal to 3. Right? So E, okay, E, we have 4 by 4. Okay, and because we change column, we have to put negative in front. And then we change again the rows. Letak lagi negative. That's why it will be negative 1 become positive because of negative, right? And then you zero out whatever left below the diagonal. So you zero out 3 here. So using this formula, so you have your matrix in triangular form. So what you do is multiply diagonal macam biasalah. So this will be your determinants. Okay, this is calculating determinants using triangular using reductions lah. All right. F also sama is 4 by 4. So because of change column, you put negative and then zero out negative 2 and negative 2 using this formula here, these operations. And then you change column again. So that's why negative hilang because of negative. And then you zero out all the numbers below diagonal using the operations. How do you decide the operations? It's up to you. So that's why you need a lot of practice in order for you to immediately understand supaya awak cepat, you really know what operations needed to zero out the certain numbers lah. Okay? And then once it is in triangular form, you just multiply all the diagonal, then you have your determinants equal to negative 50. Very straightforward. It's just that the problem is for students, the problem is usually in the reductions. So one step salah, then the whole thing salah. Then it means that there's possibility that you're gonna calculate determinant salah because of the reductions. That's why do a lot of practice in reductions. Okay. Okay, number 3. So number 3, if you have a matrix, this matrix equal to 5, find what is the determinant for this matrix. So basically you have to understand the concept. The matrix, when it undergoes a reduction, kalau dia undergo reductions, doesn't matter what shape it is at the end of the reduction, the determinant is always the same. So it's actually you simplify the matrices. You did not change the matrices, you just simplify the matrices. It is the same matrices, it is the same matrix, it's just that you simplify the matrix, you reduce the matrix, but it is actually the same matrix, and so the determinant will stay the same. Macam ini kan, this matrix and this matrix will have the same determinant. It's just that you reduce the matrix to simplify the matrix. So in this case, this is the first matrix given, right? It's equal to 5. So when you try to, how do you make this matrix become this matrix? Is using reduction. You can see that, kalau tengok pun dah tahu kan, A1 minus 3B1. So it is an operations, undergoes an operations of reductions. So when you reduce and you reduce, it's actually the determinant is always the same. So if given this matrix, and you know that this matrix is actually a product of reduction from the base, from the original matrix, so you know that the determinants will be the same. So basically the determinant is also equal to 5. Understand? Boleh?
Boleh.
Very simple kan? Alright, number 4. Evaluate the following determinants using reduction. Sama jugalah. So I'll just go through. So basically you need to understand the concept and try to do it on your own lah. So hopefully you guys have tried to do this and bukan datang kelas without trying. So before you enter my tutorial class, you should have tried the tutorial first. So you tak perlu, jangan dengar saya cakap, you actually have tried it before. So it will be easier for you to understand. Okay. So now basically this one is the same. So kalau tukar column or row, you put negative in front. And then kalau tukar row, you put another negative in front. So it become positive. And then you just reduce until triangular form. And then what you do is just multiply all the diagonals numbers and you get your determinant. Similar as B here. Upper triangular form, as long as triangular form, also just multiply the diagonal and you will get your determinant. Is already in triangular form. So if it's already in triangular form, you don't have to do anything. So you just multiply the diagonal. So you get the determinants directly. Alright. And as for D, you have to reduce lah. So you reduce until triangular form and then multiply the diagonal and you have your determinants. Right? Okay, number 5. Number 5, find the following minus. Okay, find the following minus for determinant M13. So 13 here means that you have to cover first row and the third row. And you have to calculate this. 3, 3, 1, 4, 3. That is what you meant by a determinant for minor 13. Okay. So you cover first row and the third row. Macam tu lah. And then now you find the determinant for this. So determinant is 9 minus 4 lah. How do you get 9 minus 4? Because of 3 times 3 minus 4 times 1. Multiply, cross multiply. Alright. Okay. So next is determinant 2, 3. So 2, 3 is second row and the third column. So you have to calculate 1, 2, 4, 3. So 1, 2, 4, 3. And then calculate determinant equal to negative 5. Okay. That is what we meant by minus lah. Okay. And as for 3, 1. So 3, 1, third row, first column. So you have to calculate 2, negative 3, 1, 4. So 2, negative 3, 1, 4. Calculate the determinant, you get 11. Okay. And as for 3, 2, so you cover the third row and the second column. So you have to calculate 1, negative 3, 3, 4. You calculate the determinant, you get 13. Very straightforward. Okay, so now number 6, also the same. You have to calculate the minus, but this one is 4 by 4. Means that you need to calculate the determinant for 3 by 3. Okay. So similar, kalau M12 means that you cover the first row and the second column. So you cover the first row and the second column. So yang you kena kira determinant is 1, negative 2, 4, negative 1, negative 3, negative 2, 0, negative 1, 5. So this matrix. So you calculate the determinant. How do you calculate the determinant? Using methods that we have discussed previously lah. Okay, you will get negative 23. 2, 3, sama juga, you cover the second row and the third column. So you cover the second row and the third column. Second row and the third column. So you need to calculate determinant for matrix 2, negative 1, 3, negative 1, 1, negative 2, 0, 2, 5. This matrix. So you calculate is equal to 7. How do you calculate? Using methods to find determinant. Okay. And then determinant 3, 3 means that you cover third row and third column. So you can cover third row and third column and take the remaining matrix and find the determinant. Sama juga, M41 means that you cover the fourth row and the first column and you will get the remaining matrix and find the determinant. Okay. So determinant for 41 just now, the minor 41 is equal to negative 28. Right? So apply the theorem on page 23, refer to lecture notes to evaluate the given determinants. Okay. Basically, this one is the one that we have previously, the one that we discussed previously. So 2 by 2, very simple, cross multiply and then minus. So 8 minus 1. B, similar, so you just choose one row. In this case, they choose the column, I believe. This one, choose the column. Yeah, they choose the column. So they choose the third column for this lah. But you can actually choose whatever row that you want, yet that you're comfortable with. If you not comfortable with choosing column, so then you just choose rows to do it. Yang mana yang you lebih comfortable to calculate, yang lebih, less mistake, you think that you're going to make less mistake, then you just choose that. So how you do this is just, kalau tengok ini kan, how do they do it is just they take one here and then plus minus plus, so plus 2 and then 2 cover and then this one. That's how they calculate this lah. Okay. And for C in this case, it's actually much easier if you choose, wait, they choose which one just now? If you choose, I think it's easier if you choose either the fourth row or the second row. Yang banyak zero lah, it will be easier for you to calculate lah, right? Or in this case, they just choose rows as well. 420. Wait, let me see. Anyone knows which one? Why is C solution looks like this? Saya pula confused tengok. Never mind, I get back to you with C. But actually, you can just choose any rows and you just calculate lah. D as usual, just cross multiply and then minus. And this one, cross multiply and minus. They choose this one. They choose the third row here, and then they choose third row. That's why 3 times with 3, negative 3, 5, 0. So you have 45. Okay. And for F, we have 4 by 4. So 4 by 4, so you just choose one row. In this case, I believe they choose. Okay, they choose the first row. Just first row. In this case, you can choose whatever row you want as long as you don't make mistake lah. And then you just cover. You dapat lah the remaining matrices. Because this is 4 by 4, so remaining by matrices will be in 3 by 3. Okay, so you calculate. Because of 3 by 3, then you have to do another 2 by 2. So dia lagi panjang lah because of 3 by 3, and then you have to do another 2 by 2, and then you will get your determinant. You calculate the determinant. Right, so determinant for F is equal to 0. I hope you have tried to do this and compare your answers. Okay, if you have any problem, do let me know. Alright, for question 8, let A be this matrix and find the adjoint of A. Okay, adjoint of A. So as for adjoint, you have to know the position of the positive minus. Okay, minus positive. Alright. As for A11, so A11, how do you calculate A11 is how you calculate the minor just now. Where A11 means that you cover the first row and the first column. So in this case, you cover the first row and the first column. So you need to calculate determinant for this one. 4, 1, negative 4, 4, 5. How do you calculate determinant? Macam biasalah, cross multiply. So you get 24. And here will be positive. Why? Because of the position. The position of A11 is positive. That's why you have to know the positive minus and of the position. Okay. And A12 means that you have to cover first row and the second column. Okay. So you have to know the position. If it's 3 by 3, it's positive, minus, positive, negative, minus, positive, minus, positive, minus, positive. So you have to know the positions. Yeah. So this is and you have to know this is A11, A12, A13, A21, A22, A23, A31, A32, and A33. So you have to know the position. So it means that A11 will be positive. So when you calculate A11, it will be positive determinants. Yeah, determinant of A11. So A11 you cover one first row and the first column just now. So A12 will be, it's negative, right? Yeah. So it will be negative, and you cover the second row and the salah. The second row, the first row, still the first row and the second column. So it will be negative 3, 1, 4, 5. And then you just calculate. So don't forget the negative here, negative of the positions. So A13 is here, right? It's positive. It's positive. So you just calculate. So positive. So you just calculate determinant equals to negative 4. Similar as the other position. So A21 is because of negative, and you have this. So cover the second row and the first column. So you calculate equal to the negative 42. And you calculate one by one until you reach the last position, which is A33. So A33, the position is positive kan? So tak perlu letak negative. So you just calculate the determinant equal to 30. But for adjoint, it is actually a transpose of the matrix. So adjoint is the transpose. So adjoint A, yang ini position asal kan? This is the original position, you know, 1, 1, 1, 2, 1, 3. So when you have an adjoint, when you want to, you already calculate all the minor. So when you want to include all the values into the matrix, you have to transpose. So it means that the position for adjoint will be A11, A21, A31, A12, A22, A32, and A13, A23, and A33. You see, the position is actually from the original matrix. You transpose it and become adjoint. So you calculate the minor and then you susun the minor using the position for the transpose. So you transpose the positions lah. You tak boleh lagi to this. You cannot just write A11, A12, A13 in the first row. You need to transpose the minor. Alright. So that's why you get the adjoint. This lah. It's actually a transpose. Okay. And then compute the determinant. So compute the determinant. So you compute the original determinant. Okay. How do you compute? Compute using the similar method as previously. So you just calculate. So you choose one row. In this case, they choose the first row. Okay. And then they calculate and you have determinant equals to 150. Okay. And C, we need to show A times adjoint A is equal to adjoint A times A, or also equal with determinant A times identity. So what you do is, you just multiply A and adjoint A. So you already have your A, right? A is given to you, and you already calculate the adjoint A. So you just multiply it together. So you have this as your A, and this is your adjoint A. So you just multiply. So you multiply, you get the multiplications, the matrix, the product of the multiplications will be this matrix, yeah, 150, 0, 0, 0, 150, 0, 0, 0, 150. So when you factorize 150, this is actually the identity. So it already shows that it is when A times adjoint A, you will get determinant A times with identity. Why? Because determinant when you calculate is equal to 150 just now. Okay, and then also you need to show adjoint times A. So you need to do another multiplication, adjoint A times A. So you multiply and see the answers is actually 150, also similar, 150, 0, 0, 0, 150, 0, 0, 0, 150. So you factorize, and this is actually the determinant, and you factorize, you will have equal to determinant times with identity. So sama lah. So it already shows that when A times adjoint A and adjoint A times A is actually similar, equal to determinant A times with identity. Okay, now for the inverse. So for the inverse, you can see that for the inverse, we have this formula here. So inverse A is equal to 1 over determinant times with adjoint A. Okay, this is the formula for inverse. Remember in chapter 2, we learned how to find determinant using reductions, where we do matrix A and identity dekat sebelah, and then we reduce until we have identity here, and here will be our inverse. Remember, we learned this in chapter 2 last week. This is another way for you to find the inverse, where the formula is 1 over determinant A times with adjoint A. So let's see question A. So question A, you want to find the determinant first, because A inverse equal to 1 over determinant kan? So you need to calculate determinant first, which is equal to A. And then you need to find adjoint A, matrix adjoint A. So what you do is you need to find the cofactors. You need to calculate all A11, A12 until A33. So you need to calculate. So hopefully you know how to calculate this already. So A11 until A33. So you need to calculate, and then you write your adjoint. Transpose, jangan lupa the position need to be transposed. So we have this adjoint. So what you do is, the inverse is you just masukkan dalam, substitute into the formula. So you have 1 over 4, which is determinant equal to 4 just now kan? 1 over 4 times with the adjoint. So this will be your A inverse. This is another way for you to find inverse lah, using this formula. Okay. Similarly, as B, sama juga, is just that this one is 4 by 4. So to find the determinant is much more, need more calculations. So your determinant, you have equal to negative 9 for B. You calculate the determinant, you get negative 9. And then you calculate the cofactors. Okay, you calculate the cofactors for every position. Ini tak siap ni. So you have to calculate for every position, and remember to transpose the position, and you get the adjoint. So once you have determinant and adjoint, you substitute into the formula here, then you will get your inverse. Okay. Sama juga in C. Okay, look at the C here. We want to find determinant for this. Okay, you want to find determinant for this matrix. So you calculate, and then suddenly you see your determinant is equal to 0. So when your determinant is equal to 0, if you want to substitute into here, it will not possible. It is not possible for you to find an inverse, correct? So ada dah 0 kan? So it's possible for you to find the inverse. So it means that this matrix, the inverse for this matrix does not exist. Okay, the inverse for this matrix does not exist because the matrix is either singular or non-invertible. So tak wujud dia punya inverse. So not every matrix have inverse. So macam in the case of reduction as well, last week I've shown you there is some cases where you cannot reduce it to identity on the right side. So what does it mean? It means that the inverse of that matrix does not exist because the matrix is singular. Okay, dia tak ada inverse. Okay, it's impossible for you to get the inverse. Okay, and for D, sama juga, you need to find the inverse the determinant first, and then the cofactor, and then susun all the cofactors in transpose manner. Okay, you get this, and then you substitute into the formula for inverse, and then you just get the inverse lah, alright? And E, the determinant's already 0, so you just stop there. You don't have to calculate the cofactors anymore. Kalau dah jumpa that's why you start with calculating the determinant first, because sometimes the determinant is equal to 0. So if it's 0, means that you know it is impossible for you to find an inverse. So kalau tak dapat determinant equals 0, means that there is no inverse, so you don't have to calculate the cofactor. So you just write that the matrix is singular since the determinant is equal to 0. Means that the inverse for that matrix does not exist. Okay? Alright. So now, question 10. Solve the following linear system by Cramer's rule, using Cramer's rule. So in chapter 2, we learn how to solve a linear system using reduction. We have several methods. So the first one is Gaussian eliminations. And the second one is Gauss-Jordan eliminations. So who still remember, if Gaussian eliminations, you reduce the matrix until what form? Until what form? If Gaussian eliminations, you reduce the matrix, yes, until REF. Okay. How about Gauss-Jordan? RREF. Yes, you need to reduce if Gauss-Jordan, you reduce until RREF. Okay, and this is one of the methods where you use determinants to solve the linear system. So yang ini kita tak guna, we don't have to reduce to solve the linear system. We just have to use the determinants. Okay, using Cramer's rule. Okay, now look at this. Okay, this is a coefficient matrix. How do you get this coefficient matrix? Is from this. See, here the first row, the first column is X, Y, and Z, right? So you have this matrix A, 3, 1, 1, 4, 2, 3. Okay, matrix A is equal to, the coefficient matrix is 3, 1, 1, 6, 0, -1. Okay, and the B matrix, so you need to know what is the B matrix as well. Yeah, the B matrix, apa B matrix there for this one? The B matrix is the answers here. Yeah, so the B matrix is 4, 4, 8. This is the B matrix. Okay. Okay, now the first step in Cramer's rule is, of course, you need to find the determinant of A. So the determinant of the coefficient matrix. So determinant of the coefficient matrix you calculate using the previous method. So you get 4. So the determinant of equals to 4. Alright. Now we want to find the solutions. So the solution is, of course, in terms of X, Y, and Z, right? Because of the variable here is X, Y, and Z. So the solution must be in terms of X, Y, and Z. So to find X, okay, the first column have to change the first column with matrix B, because X is the first variable, kan? So the first column here change with matrix B. So 4, 4, 8. And in the second column, just follow matrix A lah. 4, 2, 3, 6, 0, -1. Find the determinant for this. Divide with determinant of A, which is 4 just now. Okay. So if you find the determinant for this, you will get -16. And you curious sendiri lah, how do you find this determinant? Huh? So you will get -16 over 4. So automatically you get X equal to -4. So this is for the first variable. For the second variable, what you do is you change the second column here with matrix B. So 4, 4, 8. So the first column stays the same, 3, 1, 1, and 6, 0, -1. Okay, and then divide with determinant of matrix A. So you calculate the determinants, you will get 16 over 4. So y is equal to 4. And for z, for the last variable z, means that you change the third column with matrix B. So the third column with matrix B. So first dengan second, you just copy the coefficient matrix. Okay, divide with determinant of matrix A equal to, so you calculate the determinants equal to 0 over 4. So z is equal to 0. Okay. So you have your solution. X is equal to -4, y is equal to 4, and z is equal to 0. So this is how you use Cramer's rule to solve a linear system. For example, look at the last question, 11. Solve the following linear system for z. So in this case, they will just want you to find matrix variable z. So what you do is, you know that you have to identify which is your matrix B. So your matrix B here is 5, 4, 3. Okay. And matrix A, so this is your matrix A. And of course, you need to find, the first step is you need to find what is the determinant for A. So the determinant for A is equal to 1. Okay. So now you want to find only variable Z. So what you do is, the first and second column stays the same, but you change the third column because of Z. Z is the last, the third variable. So you change the third column with matrix B. So that's why this y ini, this is matrix B. So you change the third column because you just want to calculate Z. Okay. So you calculate the determinants equals to -1, I believe, and divide with 1. So you have your Z equals to -1. So what if you want to find X? So if you want to find X, so your first column have to change it with matrix B. 4, 3, -2, -3, divide with determinant of A, which is in this case equal to 1 kan. And then you just calculate. Calculate apalah, you just calculate the determinants and divide with 1. So here you need to calculate lah. So you should know if first variable, so you change the first column with matrix B. If second variable, you change the second column with matrix B. And then you just calculate the determinants, divide with determinants A. So, and that is Cramer's rule. Okay. Alright, so any questions so far for chapter 3? Any questions? You guys okay with chapter 3?
So far, okay.
Okay, you guys comfortable with reductions already? Did you do exercise on reduction? Right, that's good. So this week for lecture, it will be the last learning unit in linear algebra, which is eigenvalues and eigenvectors. So you will learn how to calculate eigenvalues and also eigenvectors. That will be the last chapter in linear algebra. And next week, I will handle the lecture next week for learning unit 5, which is we start with the studies. So this week, still linear algebra, which is the last learning unit. Also, we will release section 2, which is we two. The second assignment will be on statistics. The first assignment will be on linear algebra, which is we will cover right? So we will release the assignment on Friday. Assignment and submit in by groups. Right? Later on, I will explain to you. It will be a peer evaluation. So it means that you have to evaluate your friends. The evaluation will be in the e-leap as well. Okay? You just fill in the form to evaluate your friends in the same group dalam assignment tu lah, right? So you guys, I think it's 35 students of you. I think it's 35. I believe it's 35. I will check again. If it's 35, means that there will be one group yang buat 3 orang. Okay? So there will be one group yang buat 3 orang. Yang lain buat 2. And then one group buat 3 orang. So let me check again lah how many of you. I think it's 35. Alright. Is there any more questions on chapter 3 before we stop and before I share the QR code? No, huh?
Madam, can you repeat what you said just now? It's a very blur just now, so I can't hear anything.
About what? About the assignment, is it?
I think so. I'm not sure what you're talking about just now.
What I said is about the assignment. I will release the assignment this week on Friday. And then the assignment, you need to do it pairing, by pair. So 2 person in one group. And since your class is, I think it's around 35 students, so there will be one group consists of 3 person. Okay. And then there will be a peer evaluation as well. In the e-leap later on, there will be a form for peer evaluation where you need to evaluate your friends in the same group lah. Kan buat 2 orang kan. So seorang evaluate yang seorang buat evaluate yang seorang. And then for the 3 person, there will be there's one group that will be 3 person. So you need to evaluate 2 of your friends. Understand? If you have 3 person in one group, you have to evaluate 2 of your friends. And the evaluation have to be done within this, I will have, after you submit, then you do the evaluations lah. So I will explain more later on in the Telegram. Alright, so I think that's it for chapter 3. If you don't have any questions, so I will just share the QR code for those who have not scanned. You can scan this. So I will see you next week on Monday, same time.
Thank you, madam.
Right. See you next week.